researcher today to define obesity. When he's done hemming and hawing, he's going to say it's a disorder of energy balance. It's nonsense. Obesity is a disorder of excess fat accumulation. It's the simplest possible statement you could make. It's so true, it's a tautology. Having too much fat is a disorder of having too much fat. And once you say it's not energy balance, it's not overeating, it's not sedentary behavior, this is what we want to say about it. Obesity is disorder of excess fat accumulation. Because it's a defect of excess fat accumulation, the fat is in our body. The most likely explanation is that the primary defect is also in the body. I mean, that's where the problem is. So why go looking in the brain when you want to solve a problem that's in the body? When you get cancer of the pancreas or whatever organ, you don't go looking in the brain to see what the problem is. So there's a chance our fat tissue is regulated incorrectly. And in this hypothesis, overeating and inactivity are compensatory effects because we know from the laws of thermodynamics that if someone's if fat tissue is accumulating excess fat, if they're getting heavier, they have to either overeat or be underexpend to compensate. So the idea is we don't get fat because we overeat. We overeat because our fat tissue is accumulating excess fat. We've actually flipped the causality here. Now let me show you the analogy used by these pre-World War II physicians, researchers, was a growing child. Just to show you I'm not playing a rhetorical game here. This particularly cute ex-New Yorker, now lives in Berkeley, California. 2006, April, he weighed 20 pounds, okay? This photo is taken 3 years later. He now weighs 45 pounds. He has gained 25 pounds in 3 years. He has gotten bigger. His mass has increased. He has taken in more calories than he expended, right? He has had to. He's overeaten. But the question is, did he get bigger because he overate? Or did he overeat because he was getting bigger? He overate because he was growing. His body was secreting growth hormone. That made his body want to grow. And because his body was wanting to grow, he took in calories that he needed to think. Overeating was the compensatory effect to a fundamental growth driven by hormones. Here's another way to look at it. This is the world's tallest man, William Robert Wadlow. He was 8 feet 11 when he died in 1940 at age 20. He weighed 490 pounds. The guy was in positive caloric balance his whole life. But he did not grow to be 8 feet 11 because he was in positive caloric balance. He was in positive caloric balance because he was over-secreting growth hormone. And that drove him to grow. And so we see this guy, and everybody would agree that this guy, overeating was the effect. Hormones were the cause. Then you look at the world's fattest man, formerly the world's fattest man, and you just flip the causality and say, oh, that guy ate too much. That's why he got fat. And what I'm saying is it goes the same way in both cases. And what's interesting is if this guy walks into your office, the first thing you do is look for the hormonal defect. You have an MRI done of his pituitary gland, you find the tumor, you take it out. This guy walks into your office and you're grossed out. And then you say, how do I get this guy to go to the gym? I guess I'll send him to the bariatric surgeons because it's hopeless. So prior to World War II, this theory was called the lipophilia theory of obesity. Lipophilia means love of fat. It was a German-Austrian hypothesis. Gustav von Bergman was the most prominent German internal medicine specialist. Today, the German Society of Internal Medicine, their highest award is the Gustav von Bergman Award. He put it forth in 1908. It was taken up by Julius Bauer, professor of genetics and endocrinology at the University of Vienna. If Austrian researchers still remember Julius Bauer, here he means nothing to us. And in fact, in 1938, he left Austria when the Nazis invaded, and he ended up working in the Hospital of Medical Evangelists in Los Angeles. By 1940, this theory was more or less fully accepted in Europe. Okay? It was based on clinical observations, the kind of things I'm talking about today, and the idea that those constitutionally predisposed to put on fat have adipose tissue that's more lipophilic than the constitutionally. And the idea is like, just as we grow hair on some parts of our body and not on others, we get fat on some parts of our body and not on others. We don't get fat on our forehead. We don't get fat in the back of our hands. Some of us get love handles. Some of us get double chins or fat ankles. Fat is regionally distributed, and something controls that. And that same something, just as some people are hairier than other people, some people can be fatter than others because those same regulators of fat accumulation can differ from person to person. This is how Bauer put it in 1929. He said, like a malignant tumor, like the fetus, the uterus, or the breast of a pregnant woman, the abnormal lipophilic tissue seizes on foodstuffs, even in the case of undernutrition. People can be starving and still accumulate fat, just as they can be starving and still get cancer. It maintains its stock and may increase it independent of the requirements of the organism. A sort of anarchy exists. The adipose tissue lives for itself and does not fit into the precisely regulated management of the whole organism. So you could ask yourself, which I did, is this theory confirmed in animal models of obesity? When you make an animal fat, do you affect its brain so that it starts eating more and exercising less, or do you affect its fat tissue directly? And in every animal model I've ever found, okay, they fall into two categories. One is, this is true, that what you've done is you've dysregulated the animal's fat tissue. And the other is, nobody ever bothered to look because they just assumed that the reason their animals were now getting fat was because they were eating more. The easiest example to understand is overrectomized rats. These experiments were done in the 1970s by a fellow named George Wade at UMass. And you remove the ovaries from female rats and the animals eat voraciously and they get obese, okay? And you know, if you just do that experiment, you see this voracious eating. It's called hyperphagia. So you assume that when you remove the ovaries, what you've done is you've done something to their brain. Basically, you're removing the estrogen. Because if you feed estrogen back, if you infuse estrogen back in, you don't see any of these effects. So you remove the ovaries. They start eating voraciously. They get fat. You assume that removing estrogen has some effect in the animal's brain to make it eat too much, right? The hyperphagia. Then you can do the same experiment where you now control for food intake. You do not allow the animal to eat any more than it did prior to the surgery. And what happens is the animal gets just as fat, just as quickly. But now it's extraordinarily sedentary. Now it will not move. It sits there. Its energy expenditure goes down. So if you only did the first experiment and you believe that overeating caused obesity, you'd think removing estrogen caused the animal to overeat. If you only do the second experiment, you believe in the overeating hypothesis. You think removing estrogen makes the animal sedentary, which makes it fat. If you do both, what you realize is removing the estrogen literally makes the animal, this is actually a Zucker rat, which has a leptin deficiency, but it's a nice photo. Removing the estrogen literally makes the animal accumulate fat in its fat tissue. If the animal can eat more to compensate, remember it's getting bigger, it has to take in more calories and expends, it will eat more. If the animal doesn't, if you don't allow it to eat more, it has to expend less because it now has less energy to expend because it is losing energy into its fat tissue. What the estrogen does is it suppresses an enzyme on the fat cells called lipoprotein lipase. Okay? Lipoprotein lipase, simply put, it pulls fat from lipoproteins in the bloodstream into the fat cells. Okay? The more lipoprotein lipase you have, the more fat you're going to pull into your fat cells. Estrogen suppresses LPL activity on the fat tissue. You get rid of the estrogen, LPL upregulates, and the fat tissue starts pulling in fat. And the animal gets fatter, and it eats more if it can, and it's sedentary. And what these kind of experiments show is that overeating can easily be caused by a manipulation to the animal, an intervention that caused the animal physically to get fatter. And the way Wade said it to me, the first person who ever said this, the animal doesn't get fat because it overeats. It overeats because we have made it get fat. And we've done that by removing estrogen, which affects LPL in the fat cells. That is true of every animal model you'll find. And interestingly, Jean Meyer in 1968, my year, put it this way, said these mice will make fat out of their food. He was studying a genetic strain of fat mice. Under the most unlikely circumstances, even when half-starved. Okay, these mice were programmed to put fat in their fat tissue, and that was overriding everything else. So there's a few seemingly obvious questions you want to ask. You know, if vertical growth, obviously overeating is an effect, why not horizontal? You know, in animals, every case I've ever found, what you're doing is affecting the fat tissue, and that's causing the overeating, but why not man? And if obesity is sort of excess fat accumulation, getting back to our first principles, what regulates fat accumulation? I mean, that's the first question you should ask yourself. After you say the sentence, obesity is the sort of excess fat accumulation, the first sentence should be, what regulates fat accumulation, right? When you have one of these giants walk into your office and say, this guy's got a problem with excess growth, the first question you ask is, what regulates growth? So let's look at the regulation of fat. Fascinating history, completely ignored since the 1970s by all obesity research. Every time you tell someone they get fat because they overeat, you're ignoring 80 years of research on fat metabolism. Beautiful research. Beginning in the 1920s, I mean, when I was writing the book, I would get angry. Because I love science. This is what I've studied my whole life. This is what I've written about. It's beautiful science, completely ignored, thrown out, kicked under the rug, and then swept under the rug in the 1970s because it is inconvenient to our beliefs. But in the 1920s, research showed that fat is metabolically active. It's not an inert garbage can. If you say that fat is caused by overeating, you're implying that the fat tissue has nothing to do with it. You're just taking too many calories, it gets dumped in your fat tissue. In the 1930s, it was shown that fat in the fat cells are in a continual state of flux. Fatty acids and triglycerides are cycling within a cell, and we're going to describe that.